Welcome to today's lesson. In this first tutorial, we will graph absolute value inequalities in two variables. So now we've jumped up to chapter 2, section 2.7 and 2.8, graphing absolute value inequalities. So we've already had plenty of practice graphing equations, absolute value equations. What would happen if we wanted to graph an absolute value inequality, meaning that we have a greater than symbol or a greater than or equal to symbol or the less than or equal to symbols. So let's just start off with the main one. Here's the absolute value of x. And I see that we do have this or equal to part. So it does basically mean y equals absolute value of x. And let's start there. In this case, a, we always want to find the number that's being multiplied to our absolute value, is 1. So that's our normal value of a. H is always hiding inside with the x, and that in this case is 0. And k is always the number that's out here. Sometimes it's attached to the y, but I don't see anything, so it must be a 0 as well. Which means that my starting point is our normal starting point, 0, 0. So maybe I put a little star there. And then since my a is 1, it's just my normal outputs. Or I could use that as a slope on the right side. Up 1, right 1, up 1, right 1, up 1, right 1. I'm going to graph as many dots as I can in my graph patch. Since this is absolute value, I'm going to do the opposite on the left side, very exactly symmetrical. Up and left 1, up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1. Okay, so there we go. So since we do have equal to, I know that I can put a nice solid line for this absolute value. Because if it were y equals the absolute value of x, then we'd actually be finished right now. But we also have one other thing going on, and that's the greater than symbol. And if we're talking about all the y values that are greater than something, well, since y, the y-axis is the vertical axis and it goes up and down, it would make sense that if y is greater than, that we'd be shading up, above. So in this case, we're going to be shading everything above our absolute value. So that's how you graph an absolute value inequality. You're going to graph the v, the graph, as if it were an equal sign, and then we're going to decide if we're shading inside the v, above, or outside the v, below. And that's really it. So we do have a few symbols to talk about. If it is a less than or equal to, or a greater than or equal to, then we're going to have a solid line, meaning that we're going to graph it like we normally would with a nice solid line. If we do have a less than, just strictly less than, no equal to part, or strictly greater than, then we're going to have a dashed line. And I'll show you that on the next example. So you do have to watch out for your symbols. If you do have the equal to part, you can use a solid line. If you don't have the equal to part, then we're going to use a dashed line. And then if it's one of these guys, the less than or equal to or less than, we shade below because that's where the less thans would be. And if it's one of these guys, if it's a greater than or equal to or a greater than, then we shade above. So we're going to be doing our A, H, and K like we've been practicing throughout, but we have these four symbols that we have to pay attention to as well to see, first of all, where we're shading, and second of all, if it's a solid line or a dashed line. So these are some good notes right here that you want to take. Let's look at example 1. We have y is less than -3 times the absolute value of x plus 5. So for right now, I'm going to think of this as an equal sign. So this is like an equation. And I'm just going to find a, which is -3, h, which is, there's nothing in there, so it must be 0, and k, which is +5. So my new starting point, hk, is 0, 5. So I'm going to go to 0, 1, 2, 3, 4, 5, and put a little star. And then from there, with absolute values, I get to use this value of a as a slope, at least on the right side. So since a is -3, I can think of that as -3 over 1. So I, from my starting point, go down 3 and write 1, down 3 and write 1, down 3 and write 1. And I'm going to do the exact mirror image symmetry on the left side. So down 3, but left 1, down 3, but left 1, down 3, but left 1. Now, when you get all of your dots finished, don't be quick to put a solid line. Go back and look at our symbol. There is not the equal to part, so we don't get to do a solid line. In this case, we're going to do a dashed line. Dashed, meaning that none of the points on the actual graph are answers. None of those points will be answers because it's a dashed line. It's sort of like graphing infinite open circles. Obviously, you don't want to graph infinite open circles because that would be kind of tedious. So how we do that is we do a dashed line to tell everybody that none of this border is actually included this time. And then the last thing we have to figure out is where are we shading? If we see a less than symbol, we're going to be shading below. Shade below. So our V graph has separated our stuff from everything that's above the V and everything that's below the V. And in this case, everything below the V is actually inside the V because it's an upside down graph. So that's our graph there. Example 2. I see the equal to part, so that's good. I know I'm going to have a solid line. Let's pick off A, H, and K. A is -1/3. H this time is -2. Remember, it's always the opposite of the symbol here, so that H is -2. And since I don't see a K out here or a number out here, K must be 0. So our starting point this time is -2, 0. I will go to that part of the graph. I'll put a little star. Maybe you continue to do that. I like my little starting point. And then I'm going to do my slope, -1/3. So I'm going to go down 1 and right 1, 2, 3. Down 1 and right 1, 2, 3. I've run out of space over here, so I'm finished. But now let's make sure we do the mirror image over here to the left side. Down and left, 1, 2, 3. And that's really it. I'm not going to go off this way. Remind myself that I do see this solid line underneath. That means the equal to part. So that means that we're going to have a solid V here. And I can connect all of the points with a solid line. And remind yourself, if you see a greater than or equal to, we must be shading above. So again, this V has separated our plane into two parts, the stuff that's above and the stuff that's below. Since it's greater than, we shade above. And that's how we graph absolute value inequalities. Let's see what we have for example 3. Example 3, I've got A is 1/4. H is, I don't see a number in there, so it must be 0. And K is the -3 that I see. So here's 0, -3 as my starting point. I'm going to go straight to that. 0, 1, 2, -3 right here. Put a little star. And then my slope is 1/4. So up 1 and right 4. 1, 2, 3, 4. I think that'll be all. And up 1 and left 4, the mirror image over here. So now the question is, what am I going to do with this? Am I going to do dashed line or am I going to do solid line? Well, I go back to my symbol to tell me that, oh, I don't see the equal to part, so that's going to be a dashed line. It is a straight dashed line, so maybe get out a ruler and make your notes really good. So there's a dashed line. We have all the stuff up here, which is above. We have all the stuff down here, which is below. Let's see where I'm supposed to shade. It's a greater than symbol. So we shade above. And in this case, that is inside the V. It's not about inside or outside of the V. It's about above or below the V. And greater than means that we're shading above. I do have a part B question. It says, is the point -2,5 a solution to this inequality? -2,5. Well, let's see. Why don't we just visually look? -2, 1, 2, 3, 4, 5. -2,5 is right here. Is this going to be a solution? The answer, of course, is yes. And the reason why is it's in the shaded region. All of these points, I could put infinite points here. All of these points are in the shaded region. So all of these points would be solutions. The points that are not solutions are out here. These would not be solutions. I'm going to put X's here. None of these are solutions. So here's a good question. What if there's a point that's right on this boundary line, this V? Would that be a solution or not? Like this star, is that a solution? This point right here, is that a solution? And the answer is no. None of these points that are on the actual boundary would be solutions because it's a dashed line. The only solutions are the solutions that are above my absolute value graph. So because it's a dashed line, nothing on this border would be a solution. But this point, negative 2, 5, right here, absolutely a solution. And let's graph our last one. I'll do in red. So we've got A is 3 halves. We've got H, which is negative 1. And we've got K, which is negative 5. So I'm going to go to negative 1, negative 5, and that's where I will start. Negative 1, negative 5 is down here, put a little starting point. And then my slope is 3 halves, so up 3 and right 2. Up 1, 2, 3, and right 2. Up 1, 2, 3, and right 2. Up 1, 2, 3, and right 2. I can get 3 dots over here. Let's see how many I can do on the opposite side. Up 3 and left 2. Up 3 and left 2. I only get 2 dots here. So I see this equal to part of my symbol, so that means that we have a nice solid line. And that's not too bad. So there's my absolute value. And I need to know where I'm shading. And since it's a less than symbol, we shade below. So we have our V here, and everything below my V would be down here. Not just the part of the graph. Understand that this goes down infinitely all the way down here to negative infinity, but I'm not going to graph everything. I'm just going to graph the stuff that's around the graph patch. And part B, is negative 2, 5 a solution to this inequality? Well, let's see where negative 2, 5 is. Negative 2, 5, oh, it's that same dot right here. Is this a solution to the inequality? And clearly it is not, because it is not in our shaded region. So this is no. All of these dots up here would not be solutions. The solutions are all of the dots that are in our shaded region. And in this case, these dots along the border, every single one of them, these are all solutions because this is a solid line absolute value graph. So you know the difference between solid and dashed. Thanks for watching this tutorial. I'll see you in the second tutorial, and we'll practice more graphing next class. Bye-bye.